This conference will now be recorded.
So in the second diagram, we have three views. First one is front view and is top view as well as the isometric view. Okay. For completion of this exact object, what I need to do? Simply, I can go for this front view. Okay. Just I am drawing as it is the outer profile of the front view. So after drawing that one, I can give the thickness of 15 mm thickness. Okay, after adding that one, only what I need to do, I need to form a holes. Okay, this one and this one. After forming these two holes, what I need to do? Okay, I need to curve this exact shape. Okay, after padding this particular front view, we will get a sharp edges. Okay, in the fillet, I have already shown you how to form a tri-tangent fillet. Okay, by using the tri-tangent, just select these two edges and in removing face, select this face. Okay, this side face. Then you will get exact shape. Okay, the same tool apply for those all the four corners. So you will get this particular shape. Okay, so after doing this, your complete this exact part will be completed. Okay, so see, is that clear, ma? No, we cannot draw a front view always. Okay, based on our requirement only we can draw the tools. For example, okay, in this case also we are going to draw front view and the bottom one is half section view. So for we are going to draw front view and after that we are going to apply the holes. Okay, in the holes I already explained you now. So how to do the counter bore hole. Next one. So in this one, only one particular thing will change, which is nothing but here is a hole, but it is in a 20 degrees angle. This hole is there now, so that one. See, for this particular second diagram, you can if you draw on a top view, the steps to finish the particular part will be increasing. Okay. Okay. For example, from drawing from the drawing, I just before explaining you to draw the front view. For example, I'm now explaining to draw top view. For example, you have drawn this particular outer shape of the top view. Okay. So after drawing it, what you are going to do? You are going to pad it to this particular 20 height. Okay. You will get a rectangular block with two holes. Okay. So after getting these two, what you need to do? You need to remove these two curve shapes. 90 degrees 12 distance curve is there now. So with radius of 5. So not 5. With radius of, what is the length here? Or maybe exact curve is, okay. So here we got 5. So after drawing it, we need to forget it. Okay, we need to remove the particular curve shape. So in the top as well as the bottom. So after doing that one, what we need to do? We need to remove the rectangular shapes in the right side as well as the left side. So number of steps will be increasing. So for the first image, you are going to unable to use your contour board. I will explain you one. So no need to worry. So for example, let's finish this particular one. So whenever you are drawing whatever the image, whatever the complexity, okay, what as a designer, as you are going to design a particular part, what in your mind, you need to remember that. So all you need to concentrate is how you need to decrease the steps as many as you can. Okay. Everybody can draw. Everybody can use all the tools. But what is the specialty? Okay. So you need to shorten the path of drawing as well as the time consumption. Okay. That makes you perfect designer. Okay. So whenever you're thinking, so you need to calculate a path. Yes, you can say that a smart work also. Okay. For example, when it comes to first one, so some of them are asking about I'm unable to do the counter board. For example, I am drawing a rectangle. So here we got rectangle of a 40 by 80. So go for rectangle. I'm giving the first point and width as 80. See, I have given the just normally drawn the rectangle. Now I'm going to give the dimensions. It is 80 and now it is 40. Okay, so in here, check the diagram. So this diagram is particularly either we can form two counter boards holes or else we can mirror them. Okay, from this here 20 and this here in horizontal 20 distance, vertical 20 distance. If we make them, so we can make them mirror. Okay, instead of drawing both two holes, what I'm going to do, see, I'm going to form a symmetric line. Double click on the constraints, select the both lines which we need to form a symmetric line. Right click, allow symmetric line. You can add the vertical line as a symmetric line. Okay, the same applies to these two horizontal also. So for example, select these two horizontal lines. Okay, after that you can right click on cursor. So here allow symmetric line, select the allow symmetric line. So in for this particular horizontal line, so we are going to apply this horizontal axis as the horizontal. Now it is fully constrained. See, iso constraint and the geometric is also completely closed. Four curves closed. After that, exit workbench. We are going to exit the workbench from SketchUp to Path. So what is the thickness? So thickness is 30 mm. Okay, I'm going to give a thickness 30. Okay, preview. Okay, so we have found the basic block. Next one, what we need to do? We need to create. Okay, see, this is the model. Okay, see, for this model, we have half section view. So a section. Okay, so for this, after cutting this particular section, so what we can see, so in the top we have a small radius 6.5. On the bottom we have 11 diameter. Okay, so 11 diameter, 6.5 diameter. So for this particular one, what we are going to select bottom face. Okay, rotate this particular object. So I'm going to select the hole. So select this bottom face. So now I'm going to give the counter, change the type, counter bore. So we have diameters here. Okay, so for first give the diameter. So I'm going to give the depth of 30. Okay, next one, diameter. When it comes to diameter, so I need to give the diameter 6.5. Now give the counter board head diameter. So what is the diameter? Diameter 11 and its depth. So see, this is our head. So what is the height? 24 height. Give 24. Okay, click on preview. See, it is forming up. I will rotate for your convenience. Okay, see, from this bottom to 24 height, we are getting this 11 diameter. After that, we are for this, as per this small diameter 6.5 we have given. Click on preview, click on OK. See, this particular counter bore has formed now. Okay, so in this one, what okay. See, I have deleted my hole. Only now I have only pad, a block. So click on isometric, or else you, for your convenience, you can select the bottom. Okay, this is the face where I need to create my holes. I'm going to select a hole, click on this particular face. Okay, this rectangular face. So I need to select the position where exactly I need to give complete hole. Okay, so before that one, what I'm going to do in the extension, I'm going to give the diameter, smaller diameter, 6.5 here. So after that, I need to give the total depth of the hole. Total depth is 30. And when it comes to type, I changed the simple hole to counter bore. Counter bore. So now it will ask the counter bore head diameter. Head diameter is nothing but 11 mm. See, so this is the head. So it has a diameter of 11 and its height is 24. Okay. So now what I'm going to do? So I have given the line 11 diameter as well as the depth 24. Okay. So now in the extension only, I need to give the position where it need to be placed from each direction, from each edge. I need to give distance of 20 from the horizontal 20, from the vertical 20. So go for position sketch, click on the position sketch. So now what? I'm going to give 20 dimensions. Click on the constraints, click on edge to point. So what is the distance? 20. Click on enter. So next one, from this point to from this edge. So exact length 20. So I have modified the distances and exit the workbench and click on preview. Okay. See, I'm going to rotate object. See, completely. So this is the outside large counter head and inside this one is the exact 6.5 diameter. Okay. So now what I'm going to do, just select the hole and mirror it with respect to this particular ZY plane. Okay, for mirroring only I just created symmetric. Now select this particular plane, click on OK. So simply I got my two holes like this. So next one, you guys are asking the fourth one now. Let's see what is exactly here. So this fourth one is nothing but a bottle. Okay. So no need to worry about it, the dimensions one. So all you need to do just create half of the portion. So after creating a half of the portion, you can offset and then mirror. Okay. For example, I will draw this one. Start a new part. Okay. Now go for sketch. Yes, yes, yes. We can use only the shaft of in shaft operation only. We can get a perfect shape. Okay, you cannot extrude. You cannot uh, rib or anything. Okay, you can only apply shaft operation. All the difficulties you will face only will be in sketcher only because it has so many curves. Okay, you need to draw each and every curve as well as you need to constrain them. Okay, let's see. So in the board from the beginning, what is the length? So total length is 320. Okay, and the diameter is 75. Okay, so which gives the bottom 75 and the top we have 30 diameter. So from the center we can draw 15 diameter. Okay, so after drawing this particular 15 diameter, see, I'm going to draw a line. Or else we can draw axis line also for a particular total height. What is the height? Total 320. So give the dimension 320. Okay. So I'm going to click on fit all in. So it will be only visible to my display. So I have given the 320 total height. So now I'm going to draw a sketch. First, I'm going to draw a line. So with unknown distance, in here we don't know exact distance of this particular line. Okay, so all the dimensions we have in the bottom only. So we need to start from the bottom for drawing it. So I just drawn a line with the 15 diameter, 15 distance. So I'll just draw a line, give the dimension from here to here. It should be 15. So I'm only giving the distance between them. Okay, I haven't given the length of this particular line. Okay, so again, what I'm going to do, I'm going to do another line from here to see here. We have the length from the bottom to here. So what is it? 113. So I'm going to draw a line, give the dimension. So 113. Next one, I need to give the distance between them. So it is total 75 diameter. So what is the radius of this particular 175? 37.5. Am I right? Okay. So now I have given the exact length and diameter of the particular base. So after giving this one, here we need to create some curve. So for this particular curve, so between this curved line also we have curves 37.5 radius. Okay. So the same 37.5 we are going to apply them. For this one, we have a center point mark. Okay. So this height is from the bottom, we have the height of 138 up to the center mark of the particular curve. Okay. So and also we have particular this what is it called, end of the curve. Okay. So that we are going to find the distance between the endpoints of the curve. First 163 and then 113. Okay. What is the difference? 50. Right. So this is the start point and this is the end points of the three curves, not only single one. Those are three curves. So first I'm going to extend the line, or else we can think of another idea. Just for reference purpose, I'm going to draw another line from this end point to 50 distance. See, my line is not vertical, so I'm making it as vertical and measure this one. It needs to be 50. Okay. So now in here, what I need to do, I need to create three curves. So first one I'm going to draw. So I just drawn a circle with unknown radius. So it has a radius of 37.5 and distance of 138. So now I'm going to do constraints. From the center to bottom, 138. 138. But we don't know the horizontal distance. See, we haven't got any horizontal distance from the center point to here. Okay. So what I'm going to do, I'm going to directly apply the radius of 37.5. Change the diameter to radius. Now give it to 37.5. Click on OK. See, now what I'm going to do, I'm going to move this particular circle inside. So I don't know exact size. Okay. So after this one, I'm directly drawing a line. So from here to this end point. Okay. So all the complexity will only fall in this portion only. So now, so we need to give remaining from this curve to this line 37.5 fillet. I'm going to zoom it. Okay. So this line to now click on escape button. So select the select this line. and this particular circle. Now what? I'm going to give radius. So I'm going to give the radius 37.5. Okay, so now it is formed. Next one, the same applies with this one also. Okay, I just coincidence with the line to line endpoint. Okay, now I need to apply the same fillet here. Go for normal fillet from this curve and to this line. Okay, so before doing that one, let's see, we have an inclination of 20 degrees. So before applying the particular fillet, I'm going to apply this 20. Okay, and click on escape, give the angle 20 for this line to vertical. We need to give 20. See, it is an angle mark. Okay, total 20. Okay, I haven't seen it. So I'm changing it. No need to worry. Okay, so 10 we have given. Now it is constrained. Okay, so now what? We need to apply radius here as well as here. Fillets. I'm going to select a fillet. So trim on both sides. Give the radius to for this line to this line. So what is the radius of this particular curve? So 50. Here we have radius of 50. Change the radius to 50. Okay, so what is next? The last final fillet here. So this particular curve to this particular slant line here. That is 7.5. Okay, let's see. Ma'am, you gave coincidence. No, ma'am, once explained, ma'am. Okay, so let's see. Before drawing the curves, I have explained you one thing. So what is which is nothing but so from the end point, see up to this particular 113, only line will be left. Okay, so after this one, up to this particular slant line, the particular this line, so only line will be there. Okay, so in between these two lines only, we have three curves. Okay, we have calculated the exact length between the lines. So which is nothing but 50. So for that 50, we have drawn additional line here. Okay, so we have drawn additional line. So after drawing the additional line, we gave the radius. But what happened? The base line, 113 line is removed. Okay, so we don't want to remove the 113 line. So what I have done? Okay, sorry for the disturbance. So what we have done, we just join the end point of this line with respect to another 50 length line. Okay, by using coincidence. Okay. Now what I'm going to do, I'm going to remove this unnecessary line. So what we have drawn for the 50 curves distance, I just deleted it. Now just a minute. There is a relation in between these two lines. Okay, this is nothing but coincidence. Okay, the relation is found in between them. Okay, so I'm going to delete it and giving it the same coincidence in between the curve on this particular line. Okay, select the constraints, select these four lines and curves. It is not giving the coincidence. Okay, let's see. Let's see what is the modification point. Drag this one. Okay, we don't know exact length of this line, so that is the modification point. Okay. Okay, let's give the 163 to up to this point. Okay, so that it will constrain. Previously we have removed that particular line now. Give the constraint from this point to bottom line. So this is 163. Okay, so now it is fully constrained. Okay, let's see. See, under constraint with respect to this curve, we need to trim this curve now. So select the trim or else quick trim. Just erase those lines. Now check the constraints. Still under constraint. So for the details, you can go for sketch analysis. See, one point here, only a single point is under constraint, which is nothing but this end point. So for doing the constraint, we need to give exact some distance or dimension for that one. Okay. See, this end point. Okay. After doing all the things, we need to check the geometry also. In the geometry, just a minute. So first one is an open, isolated, open, isolated. Let's see. This is the open 5 curves. Next one line isolated. Next circle. It is an open. Next one isolated. Okay. So I'm going to delete this particular line. Okay. Now we have two open curves. So we need to join these two. Okay, up to here and up to here. So I'm going to close this one. So why we have formed two curves means we have drawn a complete circle. But what happened means we haven't erased some portion of the circle. Then only we got the like two curves. Here you can observe this small portion making the difference, like two curves. So now what I am going to do is erase this particular small portion. So you can check the analysis now. Geometry, it is open but completely a single curve with forming say segments of 7 curves. Okay. Now it is single curve. Next what? We need to offset this entire 7 curves with some distance. Let's see. Do you have any distance here? What is the exact thickness of this one? Okay, here 3 mm. So from outside to inside 3 mm thickness. Okay. I'm going to select entire sketch. So before that one, so we have a bottom portion. We forgot about the bottom portion. Okay, with radius 60, we have to join this one. Okay, let's see. Now I'm going to select a single circle. Circle center point as the vertical center point. I'm just drawing a circle. Next, observe once again. It is the radius of 60, and the end point is filled with 5 radius. Okay. Now go for constraints. It is 60, 60. Now move the circle to upward direction for our convenience. Okay. After moving this one, zoom. We need to give five fillet. Select the first fillet. Select the. So for moving, you can directly select the center of the circle and move in any direction. Okay. If you don't have constrained the particular direction, you can give any more. You can do the object in that direction. So it has a 5 radius. We can okay. After that one, we need to connect this endpoint to horizontal. See, so for total distance 50, we need to connect this line curve to bottom. See, select this constraint, select the curve as well as the particular horizontal. Make them tangency. Now it is fully constrained. So now what I'm going to do, I'm going to remove this remaining circle. So go for quick trim, select this circle. Okay, we have removed. So now check the sketch analysis. So geometry is 9 curves with open. Okay. Okay. Next diagnostic, we have completely constraint. Okay. So we have first point under constraint. So we should have another point. Leave it. So after doing this one, what I'm going to do? I'm going to offset this one. Okay. Or else we can directly mirror this entire sketch and then offset it. Measure with respect to vertical. First select all the segments. First one, second one, third one, fourth one, fifth one, next sixth. So when you are selecting, you need to be more careful. Why? Because we have small curves. Okay, if you are facing any difficulties, you can zoom the entire diagram. Okay, by using pen, you can move elements and then select the remaining segments. Now I have selected all the segments. Now go for mirror. Select the vertical line as reference. Okay, now it is formed. Now I am once again checking the sketch analysis. Okay, so still with 18 curves, it is showing opened. Okay, now what I am going to do? I am going to form. Okay, I forgot one thing. So we are not drawing any sketch. Okay, we don't need remaining portion. So I forgot that one. So what we are going to do? We need to offset this particular half section and we need to apply the shaft operation. Okay, so go for offset. Okay, so what I'm going to select point propagation with the distance of 3 mm, enter. See, it is forming in outside. We don't need in outside, we want in inside. Okay, now we are given 3. Next, what we need to do, these two are not connected. We need to connect them. Okay, for revolve, for applying shaft also, we need a closed, enclosed one up to here. And then the top also, we need to connect those two lines from here to here. So for doubling the line, we are going to apply the offset. In the mirror, last option is offset. Once again explaining, just a minute. Okay, so up to here we only have one sketch. After selecting all the edges, I mean each and every line, curves, everything, just select on the offset. So we are going to give offset distance. Okay, 3 offset distance, and we need we need to give the direction also. In which direction we are going to offset. 3, enter. Okay, so like this we will get the second one. Okay, after getting this second one, we need to give the distance in between, and we need to close the ends. Okay, in the top we have done, in the bottom also we need to close that one here. So from this end point to this end point. Okay, so still it is in offset. Let's see. So the curve points, everything, we don't have any dimensions. So what I'm going to do, I'm going to give the offset distance. Tangents, relations, everything we haven't given the, so that's why it is showing like this, or instead of this one. Just a minute. So I'm going to select entire object with the relations. So we need tangential relations for all those things. For each and every curve, we cannot give tangency as well as the constraints of everything. Okay, I have selected these curves, and now I'm going to select this bottom curve and zoom in the bottom position. See whether the tangent relation in the curve is selected or not. Okay, it is selected. So now apply the offset. It is not selecting. I need to select once again. So that is the problem. So if we don't select entire relations, we cannot get them for constraining. Once again. Now I'm going to give some distance. Still we need to do all the relations, but okay, these are two open curves. So I'm going to close those curves. Constraints, sorry, not constraint. Just directly give the distance between these two. And in the bottom also you need to use closed one. Now check the sketch analysis. Now it is closed one, but it contains a lot of under constraint objects. Okay, so you guys know how to apply constraints. So now what have I have done? Just I given the distance. So just do all the so zoom it and give the dimensions and relations also. For example, so for this particular curve, I need to give tangent relation. Go for constraints. See, for this particular curve to this one, I need to apply tangency, and as well as the for the bottom one also, I need to apply tangency. After that, I need to give the radius. Okay, so after giving that one, I need to give the angle for this one also. Next one, I need to apply tangency here also. So the same previously what are the angles we have measured, everything we need to give in a repetitive manner. Angles as well as the relations. Next one, this radius. Mm. So why we are giving tangency there means there is a relation. Okay, so point provocation relation should be there. Like for a particular point, line endpoint to this next one, we need to form a tangency, and also we need to give a connectivity. For given this one, let's give an endpoint. We have given the tangency here and the radius. In the final, let's once again check the curves. So the curves are not exactly in position. Okay. So I'm going to give the distance. Okay. Next. Let's once again check them. See, after giving the distance also, it is moving. I have given the distance between these two curves. Now let's check. Okay. So almost up to here, everything is constant. So once again, zoom the particular area. So in the middle, we need to apply connectivities. Okay. So from here to here, or else you can try to see. It's okay. We need to give the offset distance here. So from this curve to this one, same, the same. Here also, this curve to this one. Okay. So up to here it is constrained. So I think everything is constrained now. Okay. Let's check the sketch solving status. So under constraint, points are under constraint. Let's see the geometry. This point and second one is line and point. Okay. So I will click on reframe. So reframe is nothing but it will show, it will highlight. Okay. Okay. This is an under constraint. So let's give the constraint. And once again, so I'm going to give the dimension. So we haven't given any dimension here. So from here to here, so it is over constraint. Um, this is also over constraint. Let's see. Okay, height it is asking. We need to give the height, total height. Or else we can do one more thing. So we can apply collinear up in the top. Okay, either we can give the total height or else we can give the collinear in the from the point to this point. See, select these two endpoints. I'm going to use collinear. So coincidence, no coincidence. So we will give that dimension from the bottom. So once again check this. Okay, iso constraint. And when it comes to geometry, so diagonally and completely iso constraint. Go for geometry, this is a closure. So we have done the both things. Now exit the sketch. So this is the profile. So by using this profile in the 3D model, what I'm going to do? So I'm going to apply a shaft operation. Okay, I need to rotate along the z direction. Okay, see, automatically the axis has taken. So now it is rotated. Next, up preview, click on OK. So this is the shape. Okay, so we already lost 1.5 hours for this particular diagram. Okay, so now all of you understand now. Is there any doubt in this particular diagram still? So, all right, ma. So in the previous session, okay, up to where we have discussed, only we explained about in the data feature, only we explained about repeat the shaft. See, shaft is an operation which will form a material along the axis we have given in a rotational manner. So for that one, all we need to do is one closed profile. For example, so in this one, see, if I delete the particular shaft, the sketch will also completely delete it. So what I'm going to do, I'm going to form a duplicate of sketch 1. Okay, so now I have sketch 2. So now I'm going to delete this particular shaft. Click on OK. So my sketch 1 and shaft both will be completely deleted. Okay, so before that only I created a duplicate of sketch 1. Now what? I'm going to apply shaft operation. So it will ask the profile. Okay, total 360 degrees I needed, and it will ask the profile. So this particular sketch is my profile. After giving that one, I need to give the axis. Okay, so I need to select the axis here. So Z axis is my axis. Click on preview, click on OK. So this is how we are going to perform a particular shaft operation. Okay, so after this one, so let's continue with our normal daily session. So up to this edge fillet we have completed. So from the chamfer we need to discuss remaining things. Okay, so I'm going to open new one. See, in the shaft you can use a thickness 3 mm, but not this one. Okay, so this one, for this particular one, you cannot give the thickness 3 mm. Okay, why? Because it is not a complete profile we are drawing. We are only drawing a particular half of the portion. Okay, if we have complete portion, so then only we can apply 3 mm. Okay, beforehand only we are giving the 3 mm thickness offset. So if you give again 3 mm offset, it will add like 6 mm. Okay, for example, see, in the shaft I am going to edit this one. So basically what we have given, we haven't given any thickness. So I am going to click on thick profile. So in this one, it will ask thick 1, thick 2, or else natural profile may changes. Okay. So what will happen? We can, if already we have given 3 mm offset here. So I'm going to increase it. For example, 3 mm. So click on preview. See, there is no. Okay. So I'm going to select the natural fiber. So both edges will be, both side will be thick, enlarged in the thickness of 3 mm. So we will add 6 mm. Okay. So if you are if you haven't added any thickness in the offset, so like just a minute, I'm going to open a new one. So don't. Okay. So if you haven't added any offset in the sketch, for example, I'm going to select this particular axis system for my sketch. So wider I have taken. So now I'm going to apply a curve like this. Okay, you haven't drawn any offset now, so I just drawn this like this. So what I'm going to do, I'm going to, for example, I'm explaining now. This is not the shape. For example, I'm explaining. So I'm going to add a shaft. See, now sketch is already there. Axis, we are going to select this axis. Okay, the sketch has to be closed. Okay, so for applying the shaft operation, the whatever the sketch we are going to apply, okay, so that should be a closed one. Okay, So we haven't even see. So we have opened. This is a open curve. So the same applies to particular 6 sketch also. If you haven't applied any offset, okay, 3 mm offset, the sketch is not a closed one. For a closed object only we can apply a short operation. If it is not a closed one, it will show the error as we have seen before. Okay, see, whenever I have selected this, this is the sketch, this is the axis. See, the sketch selected sketch has to be closed or to be closed by the axis. Okay, like this the error will be there. Okay, so okay, up to here we all understand. So next one, for our next class of features, I am going to draw another block. So pad, select this XY, go for sketch on this plane. A rectangle I am going to draw. Exit the sketch. Okay. So now I'm going to give some thickness. So 20 is there. I'm going to apply mirror extent. So it will add another 20. Preview. Oh, okay. So now it has a thickness of 40. Okay. So I'm going to apply chamfer. Okay. In fillet, what we are going to do, every sharp edges perpendicular faces, we are going to remove the corner, sharp corner, and add a smooth edge. Okay, so when it comes to chamfer, we will just it will be a cut edge. Okay, we are going to cut the edge by using two methods. One is length and length method, and second one is length and angle method. See, select the chamfer. Okay, so in the mode you will ask length and angle, or else you can drag down this one length and length. So we have two types. But in some cases we will get both lengths. Okay, in that cases we are going to apply length and length. So in length and length, what we have to give the length one distance and length two distance to be removed. Okay, for example, in length one distance I need to remove 20 mm. Okay, so in length two I'm going to remove 10 mm. Okay, either we can give the same length in length one, length two, or else we can vary the length. Okay, so as one, so when I'm going to select, so length 120, length 2, so 10, I have given the distances. Now object to be chamfered. So I'm going to select this particular edge. See, 20 mm is vertically downward and 10 mm is horizontal. Okay, for example, I need to change the distance. 20 mm I need to remove in the horizontal distance. So for that case, I can directly select the arrow mark, or else in reverse in the box only we can select the reverse. Okay. Now we can remove the horizontal distance 20 and vertical as 10 mm. Okay. Preview. Click on OK. See, like this we are going to chamfer them. Okay. So this is the length and distance. Next one. Okay. So in the chamfer only we have second one called length and angle. So we are only giving the length. For example, I'm going to give 20 mm and here is the 45 degrees. Okay. So this is the object I need to chamfer. This is the sharp edge I need to remove. Okay. So here is the 20 and 45 distance. If we given the 45 distance, the length first the same 20 will be removed in the other edge also. Okay, so for example I'm going to change the angle, so 15 degrees. Okay, so I have given the angle as 15. Now click on preview. So this is the removing. Vertically we are going to remove 20 distance, and with the angle of 15 we are going to remove the second edge. Okay, for example we don't need like this. We are going to change the direction. 20 distance whatever we are going to remove, we need to remove in horizontal. Okay, so click on the arrow mark, it will change the direction. Click on preview. Okay, this is the 20 distance I have given, and the remaining 15 degrees, this is the small edge. Okay, click on OK. So like this, we are going to remove the chamfers. Okay, so I hope you all understand. Now, like next one is drafting. Okay, in the drafting also, we have three kinds of drafting. Okay, first one is normal drafting. Second one is draft reflection line. Third one is variable drafting. Okay, for example, so I need to draft this particular page to particular angle. Okay, so select the draft. Okay, so after selecting this one, select the face to be drawn, drafted. So this is the face I need to draft. Okay, so we have 5 degrees here. So for our convenience, I'm going to increase it into 50 degrees. Okay, so next one, natural element. So it is top face is the natural element. In case we have selected this face, okay, so we need to remove the first face. Select the first face, remove. Okay, so now this is the natural element. Okay, so this face won't be changing. So in the gray color, okay, the gray this color face will be completely increasing by drafting by 50 degrees. Okay, just click on review. See, cannot initialize the operation. Okay, 1 minute. Just a minute. Once again, I'm going to select the drafting. So this is the face I need to draft, and this is my natural fiber. Okay, so now I have arrow mark in here. Okay, so this particular 5 degrees I'm going to change into 50 degrees. Click on preview. See, there is a plane shape is the shaded plane is there na? That is the angle, 50 angle. So the arrow mark is in outside. So the 50 drafting will be outside. I'm going to select it in inside. So drafting will be inside. Click on preview. See, from this edge it will cut like this. Click on OK. Okay, like this drafting will be either in outside or else in the inside. We can remove the element. Okay, remove or add. We can do the both. Or else I'm going to edit this particular draft into outside. Okay, I'm going to change the arrow. Okay, preview. Okay, so it is adding. So like this we can do the drafting. Okay, now we have applied the drafting. But for example, for some cases we will have another problem. Like for example, I'm going to add normal fillet for this particular. Yes, before that one, I'm going to delete this for particular draft. Okay, so I'm going to add a fillet in here. Okay, it is a fillet of radius 5. Click on OK. So for this particular, after applying a particular this fillet, I need to apply a drafting for this one. So in normal drafting, we cannot select this face. Okay, so when we select a single face, along with the fillet edge, it will propagate to next one. Okay, so in that case, what we need to do, we need to select draft reflection line. Okay, so this particular draft reflection line only applies to filleted edge. Okay, now I'm going to apply the same 50 and drafted face as this one and pull in direction as click on downwards preview. Wait, wait, wait. Okay, so now I'm going to do the angle. It is already I have given the face as reference and I'm selecting the graphic face here. Okay, so give the preview. Okay, okay. So I'm going the face to draft as this one. Next one, pulling direction. I'm going to increase this angle. Review. It is not open. Okay. I will explain this later, ma'am. So along with this fillet, without changing the fillet, it will draft. Okay. Something is showing like error. So I will clear that one later. Okay. So last one is variable angle drafting. So before when we draft with 50 degrees, what happens for entire edge completely entire edge is drafted with 50 degrees. Okay, uniformly. So when it comes to variable fillet, so we can vary the fillet. Okay, it is similar to the variable radius. So for each and every point we have varied the radius like this. We can insert the points and vary the angles of the drafting. Okay, so here we can just select the face to be drafted. So this is the face. So and we are going to select ref, reference. Okay, this is the reference. Okay, so automatically we will get 2 points, starting point of the edge, end point of the edge, or we can also add the points. Okay, so now I'm going to change the angle. So now it has 5. I'm going to change it to 50. Click on OK. So preview. See, in the starting point we have 5 angles, and in the end point we have 50 angles. Or else I'm going to add one more point. So in here I have added one more point. I'm going to change that angle also. For example, I'm going to give 45 or else 100. 100 it will be more. It will come outside. So what I'm going to do, I'm going to give 20 degrees. Click on OK. Okay, preview. So like this, we can add the variable drafted fillet. Okay, variable drafting. Next one, shell operation. In the shell operation, what we are going to do, for example, we need to create a tray shape object. Okay, a tray shape object will be of only some sheet metal object. Okay, like this, I need to create some object. So select the shell. This is a rectangular object. So it is a complete solid. Okay. So what I'm going to do, I'm going to remove the top face and convert the solid into a hollow object. Okay. A shell shape object. Just select the face. This is the face I'm going to remove. Okay. So remaining references faces we can select or else we can directly leave. So now it is asking us now it is asking the thickness. Okay, defaultly it will be 1 mm thickness. Okay, inside thickness, outside thickness, it is asking. So what it is nothing but from our normal profile, we can give the thickness in outside or else inside. Okay, so I'm giving it in both sides. So for that one, so I'm going to give the thickness of inside 2 mm. The same applies to outside thickness. Click on OK. See, total 4 mm we have formed the shell. Okay, a tray shaped shell. So after, okay, now what I'm going to do, I'm going to, next option is thickness. Okay, for example, I have applied, I'm going to show you top view for your better understanding. Okay, fit all in. So see, this is the top view of my particular shell operation. So for each and every edge, we have uniform thickness 4 mm. Okay, inside 2 mm, outside 2 mm. Now what I'm going to do, by using thickness operation, so isometric view, by using thickness operation, I'm going to add some thickness for this particular wall. Only for this particular edge, I'm going to add another 4. Click on OK. See, I'm going to apply the top view for your observation. So see, these remaining 3 edges will be, 3 walls will be only 4 mm. So for this particular wall only, we have added another 4, 4 plus 4, 8 mm. Okay, like this we are going to add, but add or sorry, add the thickness of this particular wall. Okay, so next one is thread or tap. So when we are doing our whole operation, we have seen the operation threading or tapping. Okay, so for this particular software CATIA, we cannot observe the threading or tapping in our 3D. Okay, even though we have formed the threading, we cannot see the threading, but we can only see the variation in drafting. So I will tell the particular tool in drafting for your understanding. Okay. So next one is remove face. Okay. So for example, for this particular edge, I am going to apply some fillet. Okay. So I am going to apply fillet review. Click on OK. So total it has formed. So by mistake, I need to remove a particular face. Okay. So I need to remove particular face. What I am going to do? So just select the remove face. In here also we have remove face is there and replace face is there. Okay, replace face will only applied in surfacing. Okay, so I'm not going to explain the surfacing tool here. Okay, so I'm going to apply remove face. So this is the fillet or else this is the fillet I need to remove. So I need to remove the fillet and I need to convert this particular fillet into normal sharp edge. Click on OK. See, now the fillet is removed and normal edges appear. So I'm going to apply the same here and here also. Click on OK. So whatever the face, okay, once again, this is the face I'm going to remove. Final, final body cannot be closed with the selected. So it is not applying because in the bottom we have 2 edges now. So we need to remove them also. For example, I am going to remove the face. Click on OK. Applying these 4 fillets, we have selected entire face of the particular object. So it is not removing individually. Okay. So for individual segments, we can remove them. Okay. For example, here is some other fillet is there. Okay, I need to remove the particular fillet. Directly remove the face. Click on, we select this particular one, click on OK. Okay, like this we can remove the faces. So interconnected objects need to be solved one by one. Okay, see whatever the modification we are going to apply. If for example we have given the thickness of some uh, 4 mm now. Okay, after giving the 4 mm, we have added another 4 mm as added the wall. Okay, these modifications won't affect the sketch. Okay, but the modifications whatever we have applied will be directly affect the drafting. Okay, sketch will be standard. Okay, so on the base of sketch we are going to just modify some thickness or like that. Sketch won't be changing much. Sketch dimension won't be changing. Basic sketch will be the same only. Standard sketch will be same only. So drafting will be modified. Okay, so this is the shell operation, and up to dress up feature we all understand now. So next one, an important one, is this transformation feature. Okay, so why I'm telling this are important. So previously we have mirrored a hole. Okay, like uh, like that we can translate. See, in the translation also we have four operations, and after that mirror and then pattern. So in the pattern also we have three types of patterns: rectangular, circular, and user definition pattern. And next one is scaling. In the scaling also we have another option called this affinity. Okay, so like this we have these all operations. We need to learn all these things. These are necessary tools now. Okay, for drawing any complex one we need to learn them necessarily. So I'm going to explain them one by one. Listen carefully. If you miss any point you will get so many doubts. Okay, so now what I'm going to do, so for the in the translation, first one, translate. Okay, for example I'm going to form, I'm going to zoom out this particular object. Okay, so observe, this is the object in the center point. Okay, so in the origin only, center axis only, the object is there. So what I'm going to do, I'm going to translate by using translate. See, do you really want to keep the translation specification? It is asking about if you are going to move the object. Okay, so if you are going to really move the object. Okay, so I'm going to really move the object. So I'm going to click on yes. Okay, so it is asking the direction. In which direction you are going to move? For example, along the y direction I am going to move. Okay, so I'm going to select the y direction. So what is the distance you are moving? So from the center point to, so I'm going to move 100 distance. Okay, click on OK. See, it is moving the it's from original position to in given direction. It is moving the. For example, I'm going to give the distance more than 100, like 500. Click on OK. So now you can clearly observe now. Initially, object is in the center position. So what we have done, we have changed the position from the center to along the y direction. We have given the 500 distance. Okay, so like this we can translate, and this normal translation will only give the only along the any direction and distance. For example, we need to rotate the object. Okay, we need to rotate the object in a certain angle along with the respect to the center point. Okay, for that one we can go for rotation, 3D rotation. Okay, again it will ask about, are you sure you're going to rotate the object. So yes, I'm going to rotate the object. Okay. So now here what I'm going to do, it is asking the axis. For example, this y-axis only I'm going to rotate. Along the y-axis, I'm going to rotate with angle of 30 degrees. 3. Okay. So I have given the 30 degrees. So now see, observe. So it is changing the orientation along the y-axis. Okay. Like this. Next one, symmetry. Okay. Symmetric is nothing but, so whatever the axis I am going to select, it will just remove the original object and copy the original object to another axis. Okay. So select the symmetry. So this is the object. Okay. So this is the object. So I'm going to symmetric it along with the ZX plane. Okay. So select this here. Click on OK. Like this, the original object will be duplicated to here. Okay. Next one, axis to axis. For example, and for this one, I need to create another axis system. Okay. So here, I need to create a point. Okay. So I'm going to give coordinates like okay, 500. Okay. I'm going to give 500 in x direction. So not in y direction. In z direction, I'm going to give 500. Okay. In z direction 500 and in y direction also 500. Okay. So now I created a point here. This is the point. So now what I'm going to do, I'm going to apply axis system in the point. So insert axis system. So this is my center point, origin point. Click on OK. Okay. Once again, click on OK. So this is the axis system we have created. Now what I'm going to do. So from this axis system, okay, this object is related to original first initial axis system. So I'm going to copy the object from this axis system to second axis system. So here, so axis to axis. Click on OK. Yes. So this is the reference axis. This is the target one. Okay. So now the object here is changing its position with respect to the axis to axis. Okay, like this. So these are the transformations. After this transformation, we can apply mirror. Okay. So in mirror is already you have seen. So this is a single object. I'm going to mirror with respect to this XY reference. Okay. Okay. So I need to fit all in so that you can see. So this is the object. So we have mirrored it with respect to XY for the bottom. Okay. So whatever the object is in the top, repeat axis to axis. All right. So for example, I need to repeat I need to move the object. Okay. For example, apply the axis. Okay. So entire objects, whatever the objects in display in the particular part body, every object will be moving. Okay. For example, I need to move these two objects, mirrored original and mirrored one, with respect to from this axis to target one this here. Okay, see, so this orange color highlighted will be our moving object, and these are all the original one is moving its position from here to this neck and second axis distance. Okay, so like this. Next one, pattern is very important. So for this pattern I'm going to create a body. That will be better. Okay, if not I will get all the things here. So both of them will be pattern. I will get confused. Okay, so I'm going to delete this particular mirror. Okay, so I'm also deleting the axis also. Okay, one axis system is enough. I don't need two axis systems. Okay, so I'm going to create another body. So here, body I'm going to create. Okay, so this is the body. Up to here, you have seen only part body. Okay, whatever the diagrams I have drawn, sketches, whatever the modification I have done, so everything comes under part body. Okay, now irrespective of part body, I am creating my own body, my own separate body. So this is the body. Here I am going to draw another sketch. Like for example, I am going to draw a particular cylinder. For easy explanation, cylinder is best. I'm going to draw it in here. Yes, exit the space. So it is given the thickness of 20. I'm going to increase it to 30. Preview. Okay. So this is the small cylindrical shape. Okay. So zoom it for your convenience. Okay. This is a small cylindrical shape. What I'm going to do, I'm going to apply pattern. Okay. For example, I'm going to apply rectangular pattern. For rectangular pattern, what will happen? In a rectangular shape, we will get number of duplicates. Okay. So I have drawn only one single element, one single cylinder. Okay. So what I'm going to do, I'm going to duplicate in rectangular position. So in parametric also, we have different inputs. Okay. So instances, length, instances, spacing, instances, length, spacing, length, and the instances and its unique space, unequal spacing. Okay. So these are all the four parameters. For example, we have we don't okay, we are going to give number of instances and spacing. Okay, so instance and spacing. So now what I am going to do? So how many I needed? So I, for example, I need a four. Okay, four instances I needed. So spacing is 20. Okay, 20 is too small. So what I'm going to do? I'm going to change the 20 into 50. Okay, so see, even 50 is small. Reference direction, I need to select this direction, x direction. Okay, so now original one is there and three duplicates are formed. Total four elements are there. 50, when we have given the 50 distance, so what happened? The objects are intersecting one another. So I'm going to increase this one 100. Review. See, so in between the spacing from one object to another object, we will have the 100. Okay, so in one direction I have given four segments. Okay, I don't want only in one direction. I need to form a rectangular segment, rectangular pattern by using two directions. Okay, x direction I already given. I need to give the second direction. Click on the second direction. In the second direction, I need to increase the instances. Okay, so for example, in the second direction, I am going to give five segments. Okay, I need to give the direction as y direction. See, in the spacing we have 20. So what happens? Each and every element is intersecting one another. So now I am going to give 100. Preview. Okay. So now see, in x direction, first direction, we got four segments, and in second direction, y direction, we got five segments. Okay. For example, we don't want in x positive we have the elements. Okay, I don't want in x positive. I need to create in x negative. So we can reverse the direction. Okay, see, in the first direction also, in x positive we have given. So I don't want in x positive. We can reverse the direction to x negative, like this. Okay, Next one, review. Okay. Up to here, you don't have any doubt now. Okay. Now what I'm going to do, I'm going to apply circular pattern for this particular cylinder. Okay. Click on circular pattern. See, whenever you are going to give patterns, observe carefully. So here what I am going to give, it is asking the instances. Here also we have some different inputs. Okay. So now what I'm going to do, instances and total angle. So this is, I need to create 5 circular pattern objects. Okay. So total angle is 360. Along the 360, I need to create 5 segments. It is asking the reference element. So this z direction is my reference element. What is happening? So entire in the second body 2, whatever the solid segments we have, entire we have complete rectangular pattern segments are there. So what is happening? So entire segments are rotating, forming the circular pattern. So I don't want entire object. Only what I needed, only one single segment is there. So how I'm going to select? In here, in the object to pattern, we need to select a single object. Okay. So then only we will get this or single segments, or else you will get entire rectangular pattern object. Okay. In here, see, angular spacing is standardly fixed to 90 degrees. So it is only showing these 4 segments, and in the original segment we are getting another 5th segment. Okay. So in simply, so we are getting 2 segments in one position. So I'm going to change the parameters. So instance and total space is not working. So I'm going to give instance and angular spacing. So I can give the angular spacing by normal equation, like 360 divided by, okay, normal equations are there now. Like that we can give the parameters, because this is a parametric software. Okay. So I'm going to give 360 divided by 5. Review. See, now we got the 5 segment now. Like this we can apply. See, one more thing is there. So only we are applying all the parameters and axial parameters. So we have crown definition. In the crown definition, we can give the second direction. Okay. In the second direction, we only get one object. So I'm going to give second. Increase the distance to 100, or else 150. Okay. So now see, this is the second direction. So whatever the segments we have given in five objects and a circular rotation, this comes to a first direction. Whatever the crown definition circles we are going to indicate, so it will comes to second direction. Okay. So 3 instances I have given. So 3 instances will be there. 3 circular patterns will be formed. Okay, with a given distance of 150. Okay, from one instance to another segment, I have given 150. Total what happened? Total distance 300. 150 plus 150. Like this, we can form this, or else we can directly simply say we can, one is enough for normal pattern. Okay, so like this we can form the pattern. For example, okay, I need to form user definition pattern. Okay, so in the user definition pattern, so what we can do, so we can position it. Okay, so I'm going to, okay, for example, so current solid object is there. If we're going to continue with this same option, we will get entire this entire rectangular pattern as our current solid. So what I'm going to do, I'm going to select a single cylinder, okay, pad 2 as my object to pattern. So now here what I'm going to, anchor positions I need to do. So I'm going to select wherever I need to place. Okay, for this one we need to form a point. right click on here, or else before only we can create the point, and in particular point we can form the object. For example, we have center point here, so I'm going to select the center point. So the exact in the center point as center we have the user pattern, and the same. So this particular one we don't have center point. Okay, or else I'm going to create some points. By using reference elements, I'm going to create some points. So here is one point. Okay, so another. Okay, so by using 3 points, I'm going to show you. So this is our object. Okay, now this is my first point and this is my second point. Wherever the points I'm going to select, the points will be added. Okay, review. Okay, so again I can use the same to here. Okay, like this. Next one. So user definition pattern is also completed. Next one is nothing but scaling. Okay. For example, I'm going to apply the scaling for this particular part body. So how I'm to see? So my working object is in part body 2. Okay. So how I'm going to change the working segment to part body? Just select the part body, right click on the part body, define in work object. Okay, whatever the operations you are going to do, that will apply to part body. Okay, so now I'm going to apply scaling. So normal scaling I'm going to apply. So this is the object. Okay, this is a single object in the part body. So ratio is 1:1 is there. 1:1 is nothing but the original object only. For example, I need to increase the size. Okay, so I need to increase this particular tray size to its twice. Okay, so I'm going to change the ratio to twice. Okay, so reference it is asking. Reference is the center point and giving. So see it all in. This is the original object. I'm going to increase the ratio to 2. So object is twice the normal size. Okay, it is the size of the object is twice to its original size. Or else I'm going to decrease the size. Okay, I'm going to decrease it to half of its original size, 0.5. See, so this is my original object. So next one, whatever the scaling I have defined, this is the half of its original object. Click on OK. Okay, see, like this we can scale the entire object. Or else we have another option called affinity. Okay, in this affinity we can change the increase the scaling in one single particular axis. For example, I'm going to change. So it is origin it is asking. So this is my origin. Okay, this is my origin. From this particular origin, in which direction I need to increase the affinity. For example, I need to increase in y direction. Okay, so I need to increase the y direction affinity ratio. So I'm going to increase it by thrice. See, so only the y direction only it will change. Okay, or else I need to increase it in z direction also. So I'm again going to give thrice four times. Okay, so in both y direction, z direction I have changed it, and I'm going to change it in x direction also with respect to thrice. See, like this, in individual axis we can change the affinity ratio. Before, now in normal scaling, whatever the scale ratio we applied, it will apply to entire object, right? So when it comes to affinity, in particular axis, in particular direction, we can change the affinity. Okay, we can change the and ratio of the scale like this. Okay, next. So up to here, everything is clear now. Okay, time is also completed. Okay, sorry, my hands. Observe, pay attention to the time.